Hello everyone, this is Natasha from NextWork here, and I am so excited to be doing another live with you all today. Oh my goodness, it is part 2 now of our Kubernetes series, and if you haven't done part 1 yet, that's totally okay. You can still do this part without having done part 1 of this Kubernetes series. It's just that when we're about to start part 2 of the series, you might find that we are repeating steps from part 1, and those steps will be a lot clearer to you if you've tried that project before too. I wanted to throw that out there in front of everyone before we start the project, so that if you decide, all right, I really want to understand every single step in today's project, you're more than welcome to click on the link to part 1 of this project series in the description box. Otherwise, I'm excited to get into the details of setting up Kubernetes deployment with you today for today's pro project. Sorry about me getting all tongue-tied today. I'm just super excited. This project has been super exciting to test within the team because you're really starting to combine your knowledge about containers, Kubernetes, and other AWS services in this project. Okay, so in this project, we're really preparing an app's backend for deployment with Kubernetes. So the key here is we're simply deploying the app's backend. We're not deploying the entire app. And in this project, we're simply in the preparation phase. We're setting things up, we're preparing it because the deployment doesn't happen in this project, but you're doing the hard yards to set it up for a very successful deployment later on in this series. Now, everything you do in this project is going to be so practical and so key to how Kubernetes deployments really work in the real world. Deployment, unfortunately, isn't just like a simple one-click process. There is a bit of a setup phase to make sure that the deployment goes well. So that's what this project is all about. All right. So what this project is carrying on from is the first part of this Kubernetes with AWS series. And in that previous project, you would have learned how to launch a Kubernetes cluster. So as a quick recap, if you're still wondering, oh, what's a Kubernetes cluster again? Well, a Kubernetes cluster is simply groups of containers that Kubernetes, the service, is managing together for you. Because what problem does Kubernetes solve? Kubernetes is here to help us with managing containers that are already running, and these are usually groups of containers that are all running similar, the same, or related applications. Now, you would be in a situation like this if you're launching or you're running a really, really big app that's containerized into many different parts, or maybe you just have a lot of traffic going into an app that's built that's made up of lots of containers, so that the moment your traffic is high, you're managing now a lot of running apps that are all trying to handle this huge amount of traffic together. Kubernetes you can think of as a container orchestration tool, which means that it helps you with managing all of those running containers by first making sure that the containers are healthy, nothing's really failing. Second, making sure that if you have any app updates, it can help roll out those updates across all of these containers for you, so you don't have to do it manually one by one. So those are two very, very big advantages of using Kubernetes. Now picture this. A team member just developed an entire application with you, and they just shared the GitHub repository of the app's backend. Are you ready to pull their code from GitHub and set the stage for Kubernetes deployment with your backend app? Let's go. So that is your brief for today's project. Now, what it means is we're going to be pulling someone's code from GitHub, and then we're going to, with that code, set the stage for Kubernetes deployment of that code. And what is that code about? Well, that code is about a backend app that your team member has just developed. So to better understand what we're really going to be doing in this project, you can have a look at this cool little diagram we've prepared for you today. So let's zoom in and take a look at it together. Now, where this diagram starts is it's split in two parts. You can think of it as steps that you would have done in the first project of this series that you'll be repeating again in today's project. So no worries if you haven't done it yet. And then the second half, this part, is about some new steps that you'll be trying, probably for the first time with this project. Now, what's happening in the middle here that both parts are sharing is EKS, our star service called Elastic Kubernetes Service. Okay, so in step 1 of today's project, we're going to be actually creating a Kubernetes cluster, which is basically a group of containers that will be running your containerized application together today. So that is going to involve setting up an EC2 instance over here, and this EC2 instance is your main instance for sending commands to Kubernetes or to EKS to say, hey, I want to create a Kubernetes cluster. Can you do that for me? So you can think of this EC2 instance as the main place for you to coordinate all the different things that you want to be doing today. All the commands that we'll be running through this EC2 instance. Now, this EC2 instance really can't control any AWS services until you give it the permission to do so. And that's the reason why you have this handy little IAM role here to give your EC2 instance administrator access so that it can have the power to say, hey, I want to create a Kubernetes cluster. Hey, I want to be working with Docker and GitHub today. Hey, I want to be working with ECR today, which is another service we're about to dive into later in this project. So that's these two things ticked off early in this project. And then later on, we're going to be hanging out with this guy called EKSCTL. And EKSCTL is a very handy command line tool that's designed to make interacting with EKS really, really easy in the command line. So you can think of EKSCTL as just like this buddy that helps your EC2 instance over here talk to EKS in a very, very efficient way. Instead of having to run 20 commands to do what you want to do, EKSCTL boils it down so you only have to run one command. And that's the reason why we'll be using this tool today too. So with the combination of your EC2 instance that's capable of running commands, we're going to equip it with the power to interact with AWS services, which is why it has an IAM role attached to it. And then we're going to install this handy tool called EKSCTL that makes it very, very quick and efficient to communicate with EKS, our Elastic Kubernetes service, to say, hey, EKS, let's create a Kubernetes cluster. So a Kubernetes cluster, again, is a group of containers that's capable of running a containerized application together. Now, it's going to be running nothing if we don't give it anything to run, if we don't deploy an application with Kubernetes. So this first part, what we're doing here is we're setting up the cluster, but we're not really like giving it food to eat. Like it doesn't really have an app to run yet. So that's the reason why we have the second part of this series today. We're kind of like giving our Kubernetes cluster food once we've created it. Okay, so we're giving it an application to run. So like I mentioned before, deploying an app takes a couple of steps. Okay, so that's why this project is about just setting up that deployment. We're like just preparing the meal before your Kubernetes cluster can enjoy a feed. And the steps that we'll be taking is still going to be from left to right. So start in the left side. We're going to be using GitHub to pull some code, the backend code that's already been created. And this backend code is going to be the thing that we want to deploy. Our end goal here is really to be able to deploy this backend code using Kubernetes. But how are we going to go from this code that you pull from GitHub all the way to deploying it over here in EKS? So there's going to be two steps that we'll be doing today to kind of bridge that gap, because EKS is capable of running code that's in your local computer, but it's not exactly the best way to do that. You're going to be needing two different things. One, you're going to be needing to build a Docker container image of that code that you pull here. You basically download the code, and then you build a Docker container image of that code. And then afterwards, once you've built this container image, you're going to go and store it inside ECR. Now, ECR is a great place to store your container images because, as you might notice, it's also an AWS service. So what that means is EKS has a very, very easy pathway to instantly get direct access to ECR, grab this container image that you've built, and then deploy the app onto all of these, onto the Kubernetes cluster that you've set up in the first part of this project. Okay, so this is kind of our journey here. We're going to be first creating this Kubernetes cluster. So we're kind of like creating a group of containers that's capable of running applications. And then once we've created that group of containers, we're going to cook a meal so that it has something to eat. Okay, we're going to build a Docker container image of a backend, of an app's backend, and then push that container image onto ECR so that EKS is an easy access, easy pathway to access it. All right, so that is what we're going to be doing in today's project. And really, the key skills to know is that by the end of this project, what are you going to do? Oops. By the end of this project, you will learn how to clone a backend application from GitHub into your EC2 instance. You can build a Docker image of the app, and then you'll push your image to an Amazon ECR repository, this thing here. Now, one thing we haven't really mentioned is that you'll be troubleshooting installation and configuration errors throughout this project. As a pro student, get ready to face some errors head on. You're going to be absolutely crushing it. You're going to push your skills to the next level as you troubleshoot these errors. And trust me, your confidence level is just going to shoot to the sky as you solve more errors. It's a very rewarding feeling when you push through one and maybe you end up landing in another error, but you just keep pushing through. And eventually, you'll be able to see a very, very successful end of the project. Our secret mission today is also to dive into the backend code, which is living in GitHub, this thing. Cool beans. Right, so let's get started by choosing our mode. As always, our live project demos will follow the high-touch guidance for today's project, which means that you will get step-by-step guidance on every single part of this project. We don't leave any detail unsaid, and if you ever get stuck, please don't hesitate to reach out to the team or get support through the community as well. Cool. Now, before we start step one, what are we here to do today? Do we still remember the goals of today's project? All right, let's give this a go. In this project, we will prepare a backend app for Kubernetes deployment. This is because Kubernetes deployment requires apps to be containerized and for there to be a container image. This project will get us to create that container image. Awesome. Now, don't forget to delete your resources. So repeat after me. Amazon EKS is not free tier eligible. AWS charges 10 cents for every single hour my EKS cluster is running. To minimize costs, I will delete all my resources today. All right, we've taken the pledge, everyone. And to clarify, that is 10 cents USD. So once you have read and understood this, paste this over here, we'll click done, and we can get on with step one. So like we mentioned, in step one, we're gonna set up our EC2 instance and our EKS cluster. So this is pretty much the setup for our environment for today's project. And if you get stuck, do check out the first project of this Kubernetes series because that entire project is about this one single step we're about to do. So in this step, you're going to be launching and connecting to that EC2 instance over here. Okay, we'll be doing that first thing. And then we're going to be setting up EKSCTL, the little tool that helps us with communicating with EKS. And then we're also going to be attaching that IAM role in the second part of this step too. Now, once we have all three ready, we can create the EKS cluster over here. So, in this step, we will set up our environment for this project by launching an EC2 instance, our command center for this project, and use it to launch an EKS cluster. This also requires the EC2 instance to have an IAM role plus EKS CTL. Feeling good. I'm feeling good about this. So let's get started by logging into the AWS Management Console as your IAM admin user. Okay, so I'm already logged in, as you can see. But if you're not logged in yet, this is the time to do it now. And if you don't have an IAM admin user yet, you can follow the link here to get the instructions on how you can get set up. So once you're logged in, as we mentioned, first things first, let's head to the EC2 console and launch the instance that we're using to be our command center. Oopsies, you can see I'm being very sneaky. I just terminated an instance from my previous run of this project. But your console might look empty like this too. If it starts with 0 instances, we're totally okay. We're going to launch a new instance after all. So we're going to launch a new instance called NextWork EKS instance. And you can easily click on this code block to copy everything that's inside. So when you paste it, it's just so simple. And once you've named your instance, make sure that you're choosing a free tier Amazon machine image. Amazon Linux 2023 AMI works a treat. And you can also choose a free tier eligible instance type. Now T2.micro and T3.micro are honestly quite similar. So whichever you pick, I don't think is going to impact your performance. But one thing to notice is that T3.micro is no longer free tier eligible. I swear there was a time when it was, but as you can see, it doesn't really seem like it's free tier eligible anymore. So we're gonna switch back to T2.micro to make sure we're choosing like a free tier eligible instance type. Unless you're happy with maybe paying a little bit for T3.micro, but again, using T2 is not going to harm you at all. All right, so let's give that a go. And we're gonna scroll all the way down until we can select launch instance. So let's launch the instance, and aha, it tries to stop us because it noticed that we didn't create a key pair. Can you remember, if you've done the previous project, whether or not we actually need a key pair? The answer is actually no, we don't need that key pair, so we can proceed without it and just click on launch instance. Okay, so why didn't we need a key pair? You might remember that we'll be sending text commands to this instance, so you're like, shouldn't we be needing a key pair so we can connect to that instance? Well, that usually is the case. But today we're going to be using a service called EC2 Instance Connect that basically lets us connect to our instance, run commands in that instance without needing a key pair at all. So once you're here, okay, in the EC2 Instance Connect page, you simply have to click connect, and then you'll get started and get set up in a direct connection with your EC2 instance. So what's really happening here is we've created a virtual server, a virtual computer in the cloud that's kind of remote. We can't really see it. But by using EC2 Instance Connect, we've kind of just created a direct bridge between us and the EC2 instance. And this is where we can send commands as the EC2 instance. It's really, really cool. It's kind of like you just have an extra computer in front of you right now. And although that computer's presence is technically not like a physical computer right in front of you. I always find this the coolest part about having EC2 instances. They're truly just like extra computers, except that they're just not physically in front of you. Okay, so first things first, now that we're all connected, is we're just going to be installing the tool called EKSCTL. Now, if you don't remember, EKSCTL is a command line tool for working with Amazon EKS. Truly just think of it as a tool that makes it really simple for us to later create those clusters with Amazon EKS. So you just have to copy and paste this command that's given to you to download and install EKSCTL. It goes through so quickly. And next up is we're going to create the role for your EC2 instance. So really what we've just done is we've installed EKSCTL, and we're now attacking the other prerequisite for us to create that cluster. It's to give our EC2 instance the permission to do anything in our AWS account. Now to set that up, all you have to do is visit IAM, the IAM console, in a new tab. Okay, and once you're here, you'll just have to select roles over here, create a new role, and over here we're giving the role to something that's can you tell which one? It's an AWS service, because we're going to be giving permissions to EC2. All right, so select next, and then for permission policies, we're giving our EC2 instance administrator access. Now, before you come at me for granting an EC2 instance administrator access, it is a good idea to mention now that granting administrator access is truly a powerful thing to do. You're giving your EC2 instance the power to do a lot of things. It's not ideal for long-term use because bless me, I'm so sorry about that, team. Let me just clean that up. And it's not ideal for long-term use because once you give something a lot of permission, your surface area, your chances of doing the wrong thing and accidentally deleting something, accidentally having your access to your account leaked, all of that can happen. But in this case, we simply don't know all the services your EC2 instance will access for this project yet. So we're just granting it administrator access for now. And the name of that role should be NextWork EKS instance role, like this. And like this. And then you can also enter a short description like this as well. Now, as you can see, it might have just mentioned there that a role with this name already exists, which is my bad, team, because I've already created this role for the previous project. Now, when you select create role, if you've never created this role before, this role will create for you. But of course, if you see that this role already exists, what you can do is you can head back to the roles page in your console, and you can search for EKS instance role like this. You just have to click into this existing role, check that it has the right permissions. Is it administrator access? And if it's good, perfect. You can move on to the next step too. Okay, so when you've created your role with administrator access, you've kind of just created this rule out there that says whoever gets this rule will have administrator access to your account. But we haven't actually attached that role to our EC2 instance yet. So to actually give our EC2 instance the permission to do things in our account, we need to do something called modifying its IAM role. So where I am now is I'm back into the EC2 instance, EC2 console, and you can find it by typing in EC2 like this, and you can even use that shortcut link to instances right away to get there. To get right here. And then when you're here, just make sure to use actions, and then under security, you can modify the IAM role. Cool. So once you're here under IAM role, select that new role that you've created, which is the EKS instance role like this, and then select update IAM role. Okay, so once that's done, it means that your EC2 instance has the permission to do things in your account now. So let's celebrate by doing something in that EC2 instance. Back in the EC2 Instance Connect tab, we're right here. Let us run that command that lets us create our own EKS cluster. So make sure to just replace your region with your AWS regions code before you press enter. Okay, so I'm just going to backspace that your region area and change this to US East 1, which I believe is the code for North Virginia, and press enter. Ah, interesting. I have a stack that already exists with this. And this error will come up for you too if you have created this EKS cluster with the exact same name for the previous project. Now I swear I've tried to delete it right before this started, so maybe something's happened for it to still be here. Ah, there we go. This thing still needs to go, so let us delete it. Okay, the delete's been initiated, thank goodness. All right, so it might take a minute or two for this delete to be complete, and then we have to wait until the delete's complete before we can actually run this command. But that's okay. I think while we wait for this deletion to finish, what we can do in the meantime is to have a go at some of these questions. So, what did you do to set up your Kubernetes cluster? Ooh, I think we went through those steps really quickly there. I almost feel nervous about whether we went through it too quickly. If you felt that was a bit too fast for you and you need a bit of a refresher, I really do highly recommend checking out the project guide or the demo for the previous project, because that project was truly all about those steps that we ran through. And if you feel like that was actually pretty simple, that was pretty easy, then, I mean, you should be proud of yourself. Let us answer this question together. To set up today's project, we launched a Kubernetes cluster today. We sure did. Steps we took to do this included, what do we do? Included launching an EC2 instance, installing EKS CTL, that we definitely did, and modifying the IAM role for my instance so that it has administrator access. We also ran a EKS CTL command. Oh, perfect. So let us click done, and that wraps up step 1 for you. I hope this has finished deleting now. Okay, it still says delete in progress, but that's okay. That's totally okay. Because in the meantime, what we could do is we could pull the code for your app's backend. So this is a great time for us to switch back into EC2 Instance Connect. Really, if you have deleted everything in the previous project successfully, you wouldn't be seeing this error. But honestly, I'm quite glad that we're seeing this error together, because seeing such red words for the first time could freak someone out. I know it freaked me out the first time I saw something like this. And really, I'm here now to reassure you that if you see this, it's okay. Just know that you maybe have to check your CloudFormation console to see if you've really deleted everything from the previous project. All right, so now that we have actually launched a Kubernetes cluster by the start of step 2, what you can do in step 2 is to get into that new phase for this project. Okay, that Kubernetes cluster has been created now. We have containers who aren't running anything really, just like running in clusters together, in a cluster together. So what we're going to do now is we're going to start to pull the code for the app's backend. We're going to start to create the meal, cook this app, this containerized app for our clusters, for our cluster to start running. So where is this backend code? Well, this backend code is in GitHub. okay, as you can see in this little icon here. And if you're wondering what is backend in the first place, the backend, when we talk about an app's backend, we're really talking about the brain of that app. An app is typically split into two parts that you can speak in a very, very high level way. One half is the front end and the other half is the back end. So sometimes you might hear someone say like, hey, I'm a back end engineer, I'm a front end engineer. And what's really happening here is the front end is really in charge of the experience of what the users can see. And the back end is really in charge of the logic that will happen when the user interacts with a few things. So let's say if you have an app that's like, let's say Netflix, which is very, very iconic for being a big user of AWS. But let's say we're Netflix. Now, Netflix's front end will include the web app that you can interact with, okay? And then another piece of front end will be like the mobile app that you can download and tap around on. Now, what will be the back end? When I select a piece, when I select a TV show or movie that I want to watch, what the backend will be doing is it is the logic that says, oh, okay, you have clicked this very specific movie. Let's say, what's a great movie that's on? Let's say you've clicked on like Stranger Things in Netflix. Then the backend is in charge of saying, where is Stranger Things in my entire catalog of TV shows and movies? And let me push that to the user very, very, very quickly so that they can start streaming and start watching Stranger Things right away. Okay, so the backend is truly doing some magic in the background so that you are, for example, processing data, you are watching a video, you are getting a form that you've typed in submitted to someone, somehow emails can land in your inbox. Things like that is all thanks to backend logic. Whereas front end is really about displaying all of that data in a way that is very, very visual, or in a way that is very, very clear to the user. Okay, so that is the split between front end and back end. And in this step, what we're going to be doing is we are going to be pulling some code that makes up an app's backend. How we're going to even do that is a 3-step process within the step. We're going to first install Git so that we can use Git to make a copy of some code that already lives in GitHub. Because what's happening here is, don't forget, your team member has pushed the backend code already into a GitHub repository. So we don't need to code all of this from scratch. It already lives somewhere, the code, and our job is just to pull it into our local EC2 instance over here. Okay, and once that's done, we're going to create an ECR repository to store a container image of the backend. That's actually for the next step. So we'll ignore this point. We'll just be focusing on these two here. Cool. All right, so I hope that is very clear to you, and we shall get started with this step. Once I just quickly double check whether this CloudFormation stack was deleted for me, so that we're all seeing the same thing. Okay, the delete is still in progress. That's okay. We can still move on to the next step. Now, if you are deploying your cluster, you're creating your EKS cluster, you might notice that your terminal is still stuck in this like blue state. It might look like this right now. It's just trying to create your resources. Now, we don't want to stop this process, but we do want to move on to some new commands. So we're going to actually head back to the EC2 console over here, select connect again, and then select connect at the bottom again, right? And you might be thinking, oh my gosh, is this gonna overwrite what I'm doing in this tab? No, it means that you're gonna be setting up 2 separate sessions with the same instance. And that's something you can definitely do with EC2 Instance Connect. Okay, so in this step, we will pull backend code into our EC2 instance. Because our app's backend has already been prepared by a team member. What we need to do now, instead of coding up backend and apps backend from scratch, is to use what's already available. Okay, so we're going to click done to that. And while your EC2 instance is busy with creating your cluster, head back to that EC2 console. And then we'll just make sure that you are in that new instance connect session with this other in this other tab now. Yeah, so you can definitely open multiple single secure shell sessions, which is what we're doing when we're using EC2 Instance Connect. What's really happening is we're opening something called an SSH session, and if you're new to that term, you can absolutely use Simplify to understand that better for yourself too. Cool. Now we're here, so we can actually in this new session with our terminal start to say, okay, while you're busy creating that cluster, in the meantime, I have some backend code that I want to bring into this bring into my project. Can you copy that code for me? Can you clone that for me? And how you do that is with a very simple command, just one line. Copy that, and we can paste that here like this. So what is Git really, and what does cloning mean? If you haven't done our Git and GitHub project, we highly recommend that you try that as well, so you can really get a vibe, or really get an understanding of what is Git. But in the meantime, you can think of Git as a version control system that tracks changes to our code and helps us collaborate with others. Git is really helpful for two things, okay, that you might have picked up on from this sentence. One is version control, so it really helps us with tracking changes that we've made to our code. The other one is collaborating with others. It really helps us with sharing code in an easy way. So we're really going to be making the most out of this advantage of GitHub in this project. Okay, this is the one thing we're going to be doing a lot of, because we're going to be cloning the repository, which means creating just this full copy of code that someone else has stored in GitHub. Now, isn't that just such an easy way to collaborate with someone else? Just say, hey, you know what, just push your code up into GitHub and I'll clone it from my side. You know, you don't need to do a manual like sending of files over. As you'll see in a second, cloning is so much faster. And once you clone, you really don't have to do any copy and pasting. You're simply just like instantly downloading an entire project's files in one go. It's so cool. So once you enter this command in your terminal, let's see if we get to clone our team members' work. And no, not yet. As you might see in your terminal as well, the command git is simply not found. Okay, that's okay. In general, seeing a command not found error just means that you haven't installed the tool that you're trying to use. But that doesn't mean it's impossible to use the tool. It just means we need to install it before we can get started. So let's install it. And then we can actually try clone the repository afterwards. So to install Git, all we have to do is run this over here, run this code block, and it lets us install Git straight away. Very nice. It even says it was all complete. So let's put it to the test and see whether we've downloaded Git by checking for its version. Okay, and we can see that there's a version number here, which means that we've definitely successfully installed Git. And what we'll have to do next is to run the commands to configure our Git identity. Now, this step isn't going to actually change much of the project later on. It's more the fact that sometimes you need to set up the Git identity so that using Git is very, very easy later on. And we talk more about this in our Git and GitHub project too. you can honestly just copy the code and just paste it and run it right away. A secret between us, you don't need to actually change the name and email in order to run this successfully, and it doesn't actually come up again in this project. It's more that we're trying to make this setup done so that we don't run into any errors in the next command. Cool. So now that we've installed Git, we've also verified that it definitely exists. Okay, over here with Git version, you should be able to clone the repository now. So let's copy that code for cloning the repository and paste that in the terminal again. Voila! As you can see this time, there's absolutely a positive response to cloning this repository. You can even see that all of these different steps, like, oh, you're cloning something into a folder called NextWork Flask backend, and then at the end there's all these details about how, okay, we're 100% done now. You have successfully copied this code that lives in GitHub. Okay, so truly I think cloning something from GitHub takes a little bit of time before you truly wrap your head around just how much simpler it is compared to options that don't involve the cloud, which is kind of like, well, imagine you still had to share like a USB, or you still had to manually copy and paste something. In our case, we've just cloned the NextWork Flask backend repository from GitHub, so we've really just automatically cloned our team members' work in an instant. This repository does contain all the backend code needed for your application, so you don't need to code anything up yourself anymore. Your team member has already taken care of all the different files that we're about to dive into in the secret mission later on as well. By cloning that repository, you've really copied all of that code into your EC2 instance, so that we know what we're going to be deploying with Kubernetes. Okay, so let's answer here. Next, I retrieved the app backend that I plan to deploy. An apps backend means the logic or the brain that defines how the app works. For example, collecting, storing, retrieving data, processing transactions, and I'm sure there's more. So you can even say connecting with other services. Oh, there was another part to this question. I retrieved backend code by... Okay, cool, that's all right. We'll just remove this part so that there's enough characters left. So sad, everyone. If you really liked this answer, please, this is your chance to enter it now into yours, or to save it somewhere, because I'm just about to delete it. So the app's backend means the logic or the brain that defines how the app works. I retrieved backend code by cloning it from a GitHub repository. Cool. So once we've cloned it and we've made our local copy, you can run this command called ls to list what is inside your current directory. And you can see very, very clearly we have a single folder. If it's a blue bold text, it means that it is a folder, it is a directory you can enter into. If you see white text, it means that it's just a file. So it's not really a folder of other files. But yes, we can confirm that we have successfully cloned someone else's work because there is a little folder filled with all of the files that we've just copied that's just been created now. Now, why does the repository name say Flask? So the reason why Flask is in the name, this thing here in the middle, the reason why Flask is in the name is actually because this backend code is built using Flask, and Flask is a web framework that developers use to create these backend services called APIs very quickly. Okay, we are using Flask for the backend because we actually will be creating and using an API in the backend ourselves. So of course we'll be using a web framework that's best for the job. Cool. Let's take that screenshot of the terminal, getting the backend with the terminal showing that the backend repository is getting cloned. And then let's add that into our project guide. Cool. So that was very satisfying, wasn't it? Just in a few seconds, we have successfully made a local copy of our team members' hard work, their backend code. So once we've done that, we are ready to move on to step 3 for this project, which is building that container image for the backend. We've got our team members' code sitting in our EC2 instance now, so is it deployment time already? Not so fast, because when you deploy a containerized app to Kubernetes, Kubernetes really needs to pull the app from a container image that it can access. No container image, no Kubernetes deployment. Okay, so you can think of it that way. What is that container image anyway? A container image is a blueprint that contains all the instructions, the code, the libraries, dependencies that you need to run an application. On the other hand, a container is the running instance created from that image. So you can think of this image that's like, this image represents the template container that all containers running your app should have. So it should have all of these instructions inside, it should have all of this code inside, all of the libraries and dependencies it needs to install. And once you have this image, Docker, every time it creates a new container for your Kubernetes cluster, will just refer to this image and be like, let me create a new container that looks exactly like this. Let me create another new container that looks exactly like your template, exactly like your image. Let me create another container that looks exactly like this image. So the reason why it's called an image is because images are like snapshots. You know, you just take this snapshot and it's like a moment in time. While a container image in this case is pretty much like a snapshot of the ideal container, what every container should look like. So every time your Docker is creating a new container, it refers to this ideal image, this ideal like picture, and uses it as a template to create all the containers that could be running your backend. Of course, this is related to Kubernetes, and Kubernetes needs container images as well, because Kubernetes uses these images to create identical containers so that your application just runs very consistently across different environments. So whether you're deploying things in the development, in the testing, in production environments, your app will behave the same way because container images are being used. Okay, so I'll let us read this explanation a second time round. And if you have any questions, you can add them to the comments. You can reach out to the team as well. Cool. So Now that we know that we need to build a container image for the backend, that's our goal for step 3. In this step, we're going to be doing that, and then we're going to be resolving 4 installation and configuration errors in this single step. I know, before you go, don't go. Just know that you are a pro, and you're gonna absolutely nail this challenge. You're gonna have it in the bag. It's gonna be really satisfying when all the errors are dealt with, and you can resolve each one in just a line or 2. So you got this. In this step, we will build a container image of the backend app we've cloned from our team member. This is because Kubernetes needs containerized apps, needs container images, in order to deploy an app consistently. Across its cluster. Cool. To build that container image, we've got a very handy command for us today. That command is called docker build, and there are a few details here that we can dive into in this banner here. But in the meantime, I just wanted to call out that you might in this project get situations where it feels like your terminal is stuck in EC2 Instance Connect. And sometimes that's just because in EC2 Instance Connect is timed out. So when it's timed out, it'll look like whatever you type, this terminal isn't reacting at all. You can see it's reacting here for me, but imagine if that white rectangle just stayed stationary on the page. When you see that happen to you, all you have to do is refresh your tab and you'll be good as new. In the meantime, let us try to run that command over here. Oh, and yep, you guessed it. We have our very, very, very first error for this step. Now, when we are wanting to run docker build, here's your hint for some of the other errors you're about to see. When we run the command docker build, we're really telling Docker, hey, can you build a container image of this app that's in my local directory? The dot means the every file that Docker needs to build that container image is in the local directory. That's what this dot is about. So what Docker will say is, yeah, sure, I can build a container image of your app. In order to do that, I'm going to need a file called the Docker file. And the Docker file is where you would write instructions to tell Docker how to build that container image. So luckily for us, we don't need to write that Docker file because our team member has prepared it already for us. It was in the GitHub repository that you cloned in the previous step. So when we ran this command, NextWork Flask backend just gives it a title. It just says, once you've created the container image, give it the title NextWork Flask backend. And then again, that dot tells Docker to find that file called the Docker file containing all the instructions for creating the Docker image. Find that file in the current directory. Okay? But before we move on, let us talk about this task here. Why are you building a container image in the first place? Once I cloned the backend code, my next step is to build a container image of the backend. This is because Kubernetes needs a container image for a successful app deployment. At the moment, we haven't prepared a container image yet. Just raw code. So let us click done. And yeah, we have this error that says command not found. Are you familiar with this command, this error? You could be now, because we saw this earlier when we were trying to pull the backend code. We had git command not found. Now it's Docker. So remember what a command not found error tells you? It means that we can't build this Docker image, we can't run this command because Docker doesn't exist in your EC2 instance yet. It's yet another tool you'll need to install before you can start instructing it on what you want it to do. Alrighty. Ooh. Ooh. Alrighty. So to install Docker so that we can use it, we just have to run this command that's about installing Docker and run that here. Whew, off it goes. Look at it go. Docker is getting installed super quickly. And in the meantime, just know that Docker is that tool that we use to build a container image of our backend. In general, you'd use Docker to create containers and container images, while Kubernetes coordinate multiple containers called clusters, and those clusters will be running the same or related applications. Sometimes it can be a bit confusing because both Docker and Kubernetes can be described as managing containers. Sometimes you'll see, oh, Docker is used to build, Docker is used to create and manage containers. And then people will also say the same thing about Kubernetes. They'd say Kubernetes is used to manage running containers. So as a little tip for you, if you see that, just know that Docker is great for managing containers in terms of managing single containers that you're wanting to run in your local computer. Let's say you just have one single container running this containerized application, and it's just in your local computer. Docker is great for managing it. It can help check and make sure that it's running. It can give you status updates, and it's just about the single container that is running individually, independently. Now you can have multiple of these individual containers all running on your computer, and Docker can handle them all because they're all running independently of each other individually. Where Kubernetes is really shining is when you have a group of containers. Let's say you have 5 containers, and they all need to be running the same application or related applications that make up this wider solution that you have. But the key here is that these containers need to be almost working together, because if one fails, there is a chance that maybe traffic isn't being served, and then traffic now needs to be spread across all these other containers and everyone gets overwhelmed. Or if a single container is running this important part of an application that other containers aren't running and it goes down, you absolutely want a new container to start back up and keep running that important application so that no other part of your app gets affected. Now, when you have situations like this, that's when Kubernetes is really shining. It helps you manage those related containers altogether. Okay, so we're going to start Docker now. And we're going to just copy that code that's already provided for us. And this code is about saying, I've installed Docker, and wake up Docker, I'm about to start asking you to do things. So we're going to just paste that command here. Okay, we've woken up Docker now. Docker is now awake. So we better give it something to do. The thing that it needs to be doing, again, is to build a Docker image. So let us run that handy command for building a Docker image again. Copy that code, paste that in your terminal. Oof, second error coming through for this step. That's right, the second error says permission has been denied while trying to connect to the Docker daemon. And that keyword, the keywords here are really permission denied. So what's happening here? We're not allowed to use Docker? Well, isn't our EC2 instance already having administrator access is something that you might be thinking. And yes, that does mean that our EC2 instance has the power to interact with AWS services. But Docker isn't an AWS service. It's its own service. So right now what's happening is we don't have access to Docker. We've installed it though, so why would we not have access? Well, it's because this command that we're running here, notice how there's no word sudo at the start of our Docker build command. It just goes straight into docker build -t yada yada yada. There's no sudo at the start of the command. But then look here, there's sudo at the start of starting the Docker service, and there was also sudo as well. I don't know if this is going to be a long scroll. Oh, it might be a long scroll, team. Okay, I'll give up if it's a long scroll. Okay, not too long. As you can see here, we had to install Docker. Oh, this is when we installed Git. Okay, I'm making a mess on the screen now, so maybe I should abandon this task, but I was really hoping to show you. Oh, okay, we're in the right place now. When we ran the command to install Docker, look at that at the start, it says sudo 2. So what's happening right now is that the command that we just ran completely failed because we are actually using an EC2 user, this user called EC2 user, to access this instance. It's kind of like how when you have your AWS Management Console, you have your root user, and then you have your IAM admin user. Well, the same thing with creating your EC2 instance. You have a root user for that instance who has permissions to do everything in that instance. And then afterwards, you also have other users who have permissions to the instance, but maybe not full permissions. That's what we're seeing at play here. This EC2 user was created back when you selected an AMI like Amazon Linux when you set up your EC2 instance. By using that AMI, we've actually let EC2 create this user for us. It was a part of the AMI's package. And what EC2 user does is that it has normal user permissions, except that if you need to do root user level things, you need to run the command with sudo at the start. Okay, so that's kind of like a deal that our EC2 user has with the root user. It's like you're simply just striking this deal that you can do everything that other users can do, but if you want to do root user level things, put sudo at the start of your command. Okay, so what is going to happen here is while we can just throw a sudo in front of our Docker build command, we're not going to do that actually, because it actually might be better practice if you're using something that will consistently be running Docker commands to just do something else to give it almost the permission to write Docker commands so that it no longer has to add sudo to the start, of everything that it runs. Okay. When we tried to build a Docker image of the backend, we ran into a permissions error that we did. We ran into a permissions error because we are logged into our EC2 instance as the EC2 user created automatically when we selected the Amazon, created automatically from our EC2 instances AMI. EC2 user can't run root user level commands by default. Oh, okay, can't run root user level commands without sudo. I'm being cheeky here. All right. So we'll enter done. So we've submitted that response. And to confirm which user you're using in the terminal, you can always just run this command called whoami. you're asking your terminal, who am I? What's my user? EC2 user. So that's exactly like what we've covered before. Because you're using the EC2 user, that's the reason why you currently don't have permissions to Docker. So let's give ourselves permissions by adding EC2 user to the Docker group, and you simply just have to copy this command to do that. Oops. Nice. And just like that, we've added ourselves to a group called the Docker group. And the Docker group is this group in Linux systems. You can think of it as kind of like an IAM user group, really, but for a Linux computer. And this Docker group is pretty much a group of all the users that have the permission to run Docker commands. By default, only the root user is inside this group. But when you ran this command, you've basically added EC2 user into this group too. So now it has the permission to run Docker commands. Cool. And let's mention that here. To resolve the permissions error, we added the EC2 user to the Docker group. The Docker group is a group in Linux systems that grants a user the permission to run Docker commands, like Docker build. Very nice. Oops, I should probably add a little full stop here. Nice, and all done. Okay, so we need to actually refresh this tab so that our EC2 user can actually come back to this terminal, come back to this session with our EC2 instance with that new Docker group permissions in place. Until you refresh or start a new session, the new permissions that we've granted the EC2 user doesn't take place. Okay, so now that that's done, we should be able to run the command to build our Docker image now, no? Let's give it a go. You can keep pressing that up arrow in your keyboard until you get to that Docker build command. So let's run this. Okay, it looked pretty promising at first, not gonna lie. But actually we have an error again. Okay, that's error number 3. Are you keeping count too? You have failed to read the Docker file because there's no such file or directory. Which can't be true. We've absolutely cloned our team members' code, and they've told us that they have the Docker file inside that repository. So what's happening here? Well, what's happening is that the command is telling our terminal to find the container image in the local directory when we clicked on that little dot here. But our terminal can't seem to find the Docker file however hard it tries. Well, can you tell the reason for the fact that our terminal can't seem to actually find the Docker file? Okay, pause this video, give yourself the chance to actually reflect on that and have a go at answering questions like that, and then come back when you're ready. Alright, so when you're ready, just run ls in the terminal and you can see, aha, we're back to what we saw earlier in this project. There is a folder inside the root directory. And as you can see, no Docker file in plain sight. So technically the Docker file just wasn't in the same directory as the terminal. Okay, so we just have to actually run this command called cd NextWork Flask backend, copy that, paste that here, and look at that, our terminal now shows us that we're inside that folder now. Well, this folder is where the Docker file exists, So we're going to give it third time lucky the chance to build our dear container image. Is it going to work this time? And it does! The command now works. Watch your terminal just update as it builds the container image, and you can even take a screenshot here as well if you'd like. Okay, you can take a screenshot here like this to keep a record of the fact that your container image was successfully built. Congratulations. So we'll drag that screenshot into the screenshot area here, and we'll upload that in. All done. Okay, so our next step is about pushing your container image to Amazon ECR, and this is where we'll stop after in the project, unless, of course, and of course you should, stay on for the secret mission with me. Cool. So now that your container image is all built, where should Kubernetes actually find that container image? Container registries like Amazon Elastic Container Registry, really ECR is what we say, are storage spaces for container images. They give container images somewhere to live. Okay, this is the key here. They give container images somewhere to live. So these container images can be accessed by Kubernetes or other services easily. Okay, if you want to deploy something, maybe even across regions, maybe across different kinds of environments, keeping everything just in your local computer is really not a good idea for security or for like risk management in case that piece of code disappears one day. So in our case, being able to store that container image somewhere safe is a huge value add for us and for this deployment process too. Okay, and recognizing that you would have seen a lot of new characters if you haven't tried these services before. So quick recap, we're using Docker to package up the app backend, and then we're also pushing that container image to Amazon ECR, which is what we're doing in this step. When it's time for Kubernetes to deploy the application, it can just pull that image directly from ECR, which is super handy. Okay. Cool. And just know that this kind of setup using container images is truly the standard way or the iconic way for deploying containerized apps. So it is definitely worthwhile giving it a go. And it's super simple too. So in this step, we will push our container image to Amazon ECR because ECR is a storage place. That gives our container image somewhere to live. Alrighty, it's super simple to create an ECR repository. You just have to run this piece of code in your terminal, and off your terminal goes with creating that repository. You can even see that there is some JSON data to give you confirmation that it's created the thing, it's done the thing. Now, if your terminal is like mine and it shows these little two dots that kind of stops you from going back to, the terminal. You can't really type commands and enter commands like this. You'll have to just press Q on your keyboard, okay, to exit that and to come back to running commands mode. That mode just now was a mode that was very friendly for reading data, but we're here to run commands. So just press Q if you get stuck there as well. Cool. And in general, we have this awesome process from writing code to deploying the app. It starts with your coworker writing code and writing that Docker file for the backend. And then your coworker actually pushes everything into a GitHub repository that you clone, and then you build a container image of the app, and then you push that container image into that repository called ECR. Once the container image is pushed, Kubernetes will pull the image from ECR, and happy days, deploys the app like this. Okay, so we have pretty much sorted this early part here, of the coworker doing their job. We cloned their work, we've built that container image, and now we need to push that container image. Okay, we're at the last of stage 2. Well, we're using Amazon ECR today in this project to store our container image. ECR is a good choice for the job because it is an AWS service and integrates well with other AWS services like EKS. This makes deploying the app even faster or more efficient. Great. All done. Okay, so this response in the terminal is really just confirming for you with you that your ECR repository has been created. And if you want that little breakdown of what's happening here, you get to see information like, oh, this is the ARN, this unique ID that belongs to this new repository that you've created. There's even something like the repository URI, which is the address for our repository that we'll use to push our container image, repository name, and this is even your AWS account ID. Okay, so lots of data pops up here. To confirm that we've actually created that repository, we'll just have to use that search bar to type in ECR like this, and then right click on it to open up ECR in front of you. And voila, look at what repository has already been created in here. NextWork Flask backend. That's right. This command that we ran in the terminal has magically created the registry that we'll be using to store our built container image. Okay, so we really are ready. We really are ready to just push our container image and store it in ECR. How shall we do that? Well, AWS probably has read our minds that figuring out how to actually push a container image into a repository is something that's a little bit tricky. So to make it simpler, you can easily click into your repository and click into view push commands like this. And there you go. Here are some commands that you need to run to go from not having connected ECR with your Kubernetes or with your project, all the way to actually just pushing the image to your AWS repository. We'll run that first command first things first. Okay, we'll copy that. And then we'll run the command in your EC2 instance connect tab. Oh, it should be this one over here. Okay, we'll be running that. Voila! It says login succeeded, so we've successfully authenticated ourselves with ECR. And head back to your ECR console's push commands window once you've done that. And just notice that what is the second command about? Build your Docker image using the following command. Do you think we'll actually need this command? Well, the answer is no. We've actually just built our container image in the last step, so we don't actually need to build it again. we can skip number 2 and head on straight to number 3, which is about tagging your image. Okay, so that was number 3. We'll just put that in here now. So that's tagging the image, and there's also pushing the image into the repository. So let's paste that here too. Very nice. As you can see, this command ran successfully without any hiccups. And then our final command was about doing that real push of our container image into ECR. Cool. And if you're wondering why we ran the commands for tagging and pushing an image, that's really best practice for keeping your things organized by using tags. And that's why we tagged our Docker image as well. So when you tag, you're kind of like giving a specific image a specific nickname. It's kind of like, let's say we have 20 different container images that we've created before, but it's because it's like V1 to V20, version 20 of the same application. So when I build a Docker container image that's like version 21, I absolutely need to add this tag that says this is now the latest image. Okay, so that tag is called latest. And now everyone around the world that is trying to pull my code can just say, oh, can you pull the latest version? They type in latest, and then which one gets pulled? Well, the one that you only just deployed because you've marked it as latest. So that is some great use case of using tagging. And when you head back to your ECR console, you can close that push commands window, and you can even select the refresh button. Okay, voila! You can see that there is a new container image in your console now, which is very handy. Now, to kind of round things off for this project, does Kubernetes only run containerized apps from a repository? You know, a repository being kind of like this public, not a public, but this online service that lets you store your container images. Does it have to be in this repository? And the answer is no. Actually, you don't have to pull container images just for Kubernetes to work. But the problem is, if you're not using that, Kubernetes wouldn't be in effect because you would actually just be, you could be using other tools maybe for deploying a container image across different containers. But in terms of actually updating all of these containers individually, that's just this whole other monster if they're not coordinated with each other. So you could have some containers running version 21, some containers still running version 5, some containers in the middle running version 18. If something like that happens, you would really, really wish that all of these containers just have the same reference point. You know, maybe the whatever image is tagged latest. So they're all just deploying something that's consistent with each other. All right, so NextWork Flask backend. I think it is time for a celebration by taking a screenshot of this successful end state like this and chucking that over into our project guide. Mint, it looks good. And let's finish things off with one of our final questions before the secret mission. What is the advantage of using a container registry? So you can start your answer with something like, container registries like Amazon ECR are great for Kubernetes deployment because, why is that? So container registries like Amazon ECR are great for Kubernetes deployment because we get to store tagged images from a single source of truth. This means that whenever we're looking, this means that whenever users or other services pull my container image, they can do it without a manual install. Oh, they can do it without a manual install, and also they can do it with this confidence that they have pulled the latest version if it has the appropriate tag. But yeah, let's make this more concise so we can fit all of those thoughts in. Container registries, like Amazon ECR, are great for Kubernetes deployment because we get to store tagged images from a single source of truth. If users or other services pull my image, we can just actually make this more concise by saying users or other services can pull my image, can pull my latest container image without any manual downloading required. That's actually such a big pro of using a container registry. This is definitely a good reminder for me as well. Okay, so what we've really done here is we have set up our backend app for deployment by creating this container image and pushing it into ECR. So hold on a second. In this exclusive secret mission, welcome to the secret mission. Your mission, should you choose to accept it, is to deepen your understanding of the backend app that you cloned. Remember how we just cloned the backend from GitHub? At the time, we didn't really need to think much about what was the code that was actually built. But this secret mission is all about it. By the end of this mission, you'll truly know what was inside that interesting Docker image that you've built without knowing what were the contents of the instruction sheet, the Docker file. So in this secret mission, we're going to get ready to open that repository in GitHub and then explore the 3 files that make up the backend that we can get into a lot of detail about. What are we doing in the secret mission? In this secret mission, we will investigate the original source code, backend code really, that we pulled, that we cloned from GitHub. This is because it will enhance our understanding of backend and what it will enhance our understanding of backend and what our team member prepared. Cool. So to show you what the backend actually does, imagine that your team member just sends you this link to search Hacker News and asks you to enter a search query in there. Open this link to search Hacker News in your computer, and you'll be able to get a big hint about what this backend does. Cool. So have a study once you've opened the link on what you're seeing and what that means for how the app should work. Cool. So ideally what you've picked up by now is you can actually change the end of the URL, and totally okay if you didn't get to do this yet, into something different like cloud, for example. Ooh, new results. And you can even do something like Amazon and see what kind of results come up. Wow, so many things come up. So what's really happening here? Well, although we haven't really seen your backend app at work yet because we haven't deployed it, your coworker explains that the backend app is actually a tool that takes a user's input, for example, AWS, or in our case, Amazon, and then it runs what the users inputted into here. So in our app, imagine someone types in Amazon, we grab that data, we're like, oh, someone in our app typed in Amazon. Let me send those details over to, let me search what they've searched in here. And once it can grab all of the possible data that comes out of the search, Uliana's app then even formats, our team member's app even formats all of that data into JSON data. So we haven't seen the backend app actually turn it into JSON yet because we haven't deployed the app, but we'll do that next week. And in the meantime, just seeing the search results page just gives you a really good idea of the kind of data that your backend is about to produce in the next part of this project, which is super exciting. Okay, so how does the backend code actually do all of this? How does it actually do all three steps? We'll find out in the code. So open the link to your GitHub repository, which is what your team member has given you. And you can see here that there are some 3 main files. You can ignore README. README is just this very, very simple file that you can see here. But there are 3 files that you can use. Dockerfile, app.py, and requirements.txt. We're going to explore all 3 of these. If you want a quick summary, requirements.txt is a file that just lists all of the dependencies that your app needs. Okay, and the Docker file here is what Docker will look to when you're trying to build that Docker image, that container image for your app. And bringing all those 2 things together, app.py is really that core file that we want to be looking at here. It is the core of the backend because it contains all the real code, the code that determines how your app works. Okay, so we'll start off with the shortest one, which is requirements.txt. And if you want a small breakdown of what are each of these requirements that we have to install here for this app, well, there are quite a few. Flask is the web framework used to build the backend code, so absolutely we need Flask to exist in order to successfully deploy or to successfully run the app that we've pulled. Then we have Flask REST-X, which is an extension of Flask that allows us to create an API. And an API is really something that is kind of like a way for users to get in touch or send data to an app. Or it's also for retrieving data as well from an app. Then there's also something called requests, and request is used to fetch data. While the last one, workzug, is it workzug? I don't know how to pronounce that. But it helps Flask with handling application level routing. So for example, what kind of functions in our main code file app.py is handling what, like who's doing what inside your solution there. Okay, now that we've understood requirements.txt, your next thing to understand is what is going on in the container image, or really the Docker file, because now you get a really good understanding of how your Docker image got built. Okay, so if we were to break down the commands in this Docker file, you have from Python 3.9 Alpine. And whatever that means, it really means that you're just setting up the environment for your app by coding or by running commands in Python now. So you can even add some metadata to your Docker file to say, oh, who wrote this file? Oh yeah, it was NextWork, for example. And you can also use directory really, to set up what kind of directory, what kind of folders the rest of all of your commands is gonna sit in. So all of these commands here are all getting run after your terminal navigates to the app folder, or like the app subdirectory. So these 4 commands get run, and these 4 commands are all about actually preparing the specific dependencies, making sure they're installed in every single container that gets created. And there's also even a command that you are almost pre-setting up. You're pretty much saying in this line, once that container exists, once it's been created, make sure that you start the app, okay, by using these 2 commands here, Python 3 app.py, app.python. Okay, let's boil down our learnings into these questions. The requirements text file. List all the dependencies and commands that every container needs to install. Oh, actually not commands, but just all the dependencies and libraries that every container needs to install when it gets created. Having a battle with spelling, but what I've added there is just to be very clear that the requirements text file lists all the dependencies and libraries that a container needs to install, when that container is created. Okay, so what does the Docker file actually do? We've actually looked at the requirements file, okay, and now next up is the Docker file. The Docker file sets up the instructions that tell Docker how it should build a container image of your backend app. It includes commands on what do you remember about the commands? So the commands are, these are all commands that will truly complete the, I would say it would truly complete the setup of a container. So it includes command on where it can find a list of all dependencies to install requirements.txt, and commands that will automatically run. Cool, we'll select done for that, and we'll truck along to that last file, which is app.python. Okie dokie. So app.python is a much bigger file, and if you're new to Python, don't worry at all. This is something that we can absolutely still talk through together in a more general sense instead of line by line. Okay, and the general sense explanation is that your code is truly split up into 3 parts here. So the first part is about just setting up the app and routing it. So it's pretty much like this section here, and really we're just trying to install the dependencies, just make sure we have all the variables that we need. Okay. And then we have the fetching data really function here. So we have something called search contents, and look at that. The URL directly references the URL that we used in order to start getting search results. Okay, so what's really happening here is we are trying to extract, actually split up the kind of data that we collect on a user when it types in a search term. And then we also get to, from breaking up that request or that piece of user data, we extract what kind of topic that they were searching for, and then we throw that topic into another API over here to find all of the content that we were seeing. It's kind of like doing the telling API to run this themselves, and then in our case, really, this isn't getting run by itself, but we are almost as the app is almost like running this query, grabbing all this data that you can see in front of your screen, and then return the data, the same data, but in a more formatted, tidy JSON response. And that's the reason why this backend exists. The front end is going to be very, very happy when it sees that the backend is capable of formatting like chaotic pieces of data into a very, very neat JSON format. Okay, so to round it up, the app Python file contains 3 main parts. Installing dependencies, we have installing dependencies. We also have formatting the data into JSON data, and then finally passing the formatted data back to the user, or in a more general term, back to the requester. All right, all done. Now we can save that, and we are almost done. Phew! That's the backend code investigation all done. Let's wrap up with a quick summary. Your app's backend fetches data based on the search topic you enter. The backend code uses Flask to connect with an external API called Hacker News Search API and process the data. And then finally, the backend then sends that data back as formatted JSON to whoever requested that data. It could be a person, a user, it could be a service. Overall, what have you learned about your app's backend from exploring all of that? Cool. After reviewing the app's backend code, I've learned that the app functions by extracting data from another API, but we also have our own API in app.python that's responsible for others wanting access to our service. Okay, very cool. All right, so classic way to finish off before we go, finish off a project before we go. Let's make sure we delete everything that we've created in this project. To start, instead of visiting CloudFormation, try deleting your EKS cluster within the same terminal. So you would have noticed CloudFormation was the previous project's way of deleting a cluster, but let us actually try just doing that within the terminal this time, so we don't even need to visit a new service. We don't even need to visit, we don't need to go kind of off this tab and off AWS, off this EC2 Instance Connect tab just to delete the cluster. Oh, let us run that again. Aha, and there's an error. It says the AWS region must be set. Please set the AWS region in the AWS config file or as an environment variable. Oh, okay. Well, let us try just setting the region manually here. Can we do that? -- region. -- region. US East 1. Oh, I see. Oh my goodness. The reason why the resource wasn't found was because I just realized that we hadn't gone back to actually creating my my EKS cluster yet. So the cluster hasn't been fully created, but as you would have noticed, we didn't actually need it for the rest of this project. It was more that this setup is going to be iterated on one more time in the next project. So that experiencing the setup in this project would have been very important for you to have your first go at setting up a cluster if you haven't done it before. But if you have done it before, set it up in an even more efficient way, and then we're going to be even more efficient in the next project and you get to see it evolve. Cool. So apologies everyone that I haven't actually created the cluster that needs to be deleted, but this command will absolutely run and delete your cluster if this is something that you've actually launched at the start of this project. Cool. Next up is to delete that command center EC2 instance that we've been using. So once you've head back to an EC2 console and into the page where you can see your instance, you just have to select it like this. Okay, and then under instance state, terminate or delete it. Select terminate, delete. And off it goes, it gets deleted. We don't have to see it again. Now, last step is to delete that ECR repository. And that ECR repository, this one over here, is also super easy to delete. You just have to make sure you're in the repositories page over here. You select the repository you've created, and you just have to select delete like this. All done. Cool. So we can now wrap up our project by reflecting on a few key questions. What were key tools and concepts in this project? In this project, we used Amazon EKS, we used Git, we used Docker, and Amazon ECR to prepare a backend app for deployment with Kubernetes. This involved setting up. This involves setting up a cluster, an EKS cluster, cloning code in GitHub, from GitHub, building and pushing a Docker image is a huge one too, to Amazon ECR. Nice. How long did it take you to complete this project? Ooh, this project took us approximately 2 hours, including demo time today. The most challenging part, my vote for the most challenging part was running into the multiple errors. My favorite part was seeing an image in my ECR repository. Cool. What is one thing you didn't expect in this project? One thing I didn't expect in this project was one thing I didn't expect in this project. Let me think. One thing I didn't expect in this project was needing to refresh our instance connect session so that our EC2 user could obtain the permission to run Docker commands after we added her to the Docker group. Thanks for doing this project. Congratulations on making it to the end. Why did you do this project today? Did this project meet your goals? Was this project challenging enough for you? Share us your thoughts, please. Please do make sure to answer this question, and also make sure that you're not influenced by whatever I type here. This is your chance to just pause this video now so you can give it a go. We did this challenge to learn about Kubernetes deployments and how they work. This project helped us learn about the importance of building a container image of our work first. Cool. All right, so that's a wrap for today's project. You have learned how to set up your app for deployment with Kubernetes using Amazon ECR, using Amazon Elastic Container Registry. Now, this consists of a few steps that we went through there. We also had to learn how to use Git to pull some application code. We also had to learn how to build a Docker image, and we also pushed that Docker image to ECR alongside troubleshooting all these installation and configuration issues. You're such a champ for making through all of them. And just know that if you can do this, there are absolutely so many things out there. Are not many things that you can't do. I think that's a better way to put it. Okay, so in the next project of this Kubernetes series, you'll be deploying the backend to see all of this work that you've done today just come to life in this live app. So lots of learnings are in store for you. See you in the next project. I hope you get excited about it, because deploying it is a whole other beast of learnings, a whole other beast of like feeling really satisfied when you can see it in front of you. All right. Oh, it says we still have tasks to complete. Is that true? it says that I have tasks to complete, which is why it can't let me get to the end yet, but I can't seem to figure out which task I haven't completed. So let me just double check that we've got everything all good and all sorted out. What's happening here? I wonder if I can see. Ah, there we go. I wonder why it wasn't clear just now and why we couldn't complete the mission at the bottom there. But at least you can see most of my documentation that was created, which you'll get access to as well once you click on mission accomplished at the end there. So look at this amazing beauty. I'm so impressed with the way it looks. I think it is an awesome compilation of all of your work so far in today's project. You have built a container image. You have learned how to clone the code that you're about to deploy. You've built the container image around the code that you've cloned, and then you've even pushed it up into a container registry. So all of that comes together really, really well for this final piece as well about your secret mission. Okay, about the secret mission where you even reviewed the app's backend code. That was awesome to see. All right, everyone. So this is really cool. You can even download this so you can save it locally. And once you have done that, it is a great opportunity for you to write a LinkedIn post about your experience. Now, I can't seem to access that LinkedIn post right now because we can't get submission accomplished, and that's so frustrating. But that's totally okay. Let's see if I can. Yeah, so your the post that you have as a template, it's gonna look something that's very similar to this. Now, this is actually the post that you'll see in the next project of this series, but this is the one that I have access to right now, so I thought, oh, maybe I can show you as my demo, because the important steps that you need to do are the same, okay? What's going to happen is you'll need to make sure that you can double click on the words NextWork like this, so you're tagging us so that we know that you've done a NextWork project and we can cheer you on in the comments too. And you can scroll down and just click on this X button over here so that you can add your own document like this. Add a document, choose the file, and select the documentation that you've downloaded like this. I think I should be able to have some example documentation that I can upload for you. So prepare for Kubernetes deployment would be the name of our document. Cool. And when that's done, just select done, and then your post and your documentation will be combined perfectly for you that you can post right away. Awesome. So I hope that was a good walkthrough of this project for you today. If you have any questions, again, don't hesitate to reach out. The NextWork community is all about supporting each other. It's all about helping each other out. It's just such a great place to be. Again, in the meantime, I hope you have fun learning AWS. I hope you have fun being a part of the community, and we'll see you in the next project. Awesome. Bye.